Dear Luan, I'm recording this video because it's quite hard to explain my doubts and questions. So let's consider our linearization attack. So our main goal is um, to find yej as multiplying state I on J, and we can consider our matrix Y as multiplying vector of states transposed on the usual vector, and we will get matrix 50 on 50, where we need just left triangle because uh, y and o is the same as y 0n. So right triangle will be the same as left. So we will have just 1275 possible yej, useful yej, and we can show this left triangle as a vector of this height, and it will be a vector y h. So as a recent main idea is that matrix qt multiplying by vector y is equal to provided list of output string, where we need just also 1275 values from 1,500. So the main question which I have, how we will how we will how looks this qt matrix. I understand how it will look on a first line where we haven't been changed states. It's an initial position. For example, from our txt file, we see, for example, that doesn't matter. For example, that s5, we need just s5 multiplied by s20. For example, it's here, and we know that some position which will be responsible for position 20 and 5 will be equal to 1. So have on our first line around 10 around 10 uh, 10 positions which will be equal to 1. But as we know, our state will, after each block, will change, and how we will show it in our matrix QNT. It's a main question. Secondly, I have an idea how we can show our calculation in another way. So let's consider that we have z of t. We have z of t. Just one. It's not matrix. It's just one value. And for example, pej, it's like it's our filter. For example, as we remember, s 20 of 5 is equal to 1, because we should multiply it, and we will say that 20 and 5 will be equal to 1. And for example that what else? For example that S1 is equal to S1 multiplied by S1, so it will be not first, it will be on diagonal, our diagonal, so it will be 1. And next question, we should it multiply by our states. For it will be responsible these parts, left and right, here and here. And here I understand how to show that how to show that how to show that our states are changing. So we have multiplied one moment. I'm sorry. I return. I'm back. So here we have x of t. It's initial state vector transposed, which we want to find, and it is multiplied by our companion matrix in power of t. For example, we have t is our is number of current state, and we multiplied it by matrix p ij. We have already considered what is it, and then we multiplied secondly on our state, so initial state and companion state in power of t. I'm sorry, t minus 1, t minus 1, t minus 1, and initial state, and we will get our value of zt. Why? Because here we will have matrix of dimension 1 on 50. This matrix is 50 on 50. Here we also will have matrix 50 on 1, but as we remember, this matrix is transposed, this not, so here is 50 on 1, and in the end we'll have our one value, z of t, and the main question how to solve this equation, and we need somehow transfer it to the big matrix, because we have many values, output values, 1275. So how this equation transform to many equations into into one matrix? So I have two questions. Let's sum up. First, how to show that our state is changing in case if we use y, and if we are going to do it another way, as I showed here, how to solve such equations. I understand that we can, for example, multiply this three matrix, and it will be equation in form xt multiplied by a and multiplied by x equal to z. But we should have many such equations, around 1275 such rows, and how to convert it to such matrix. I don't know. Okay, thank you for attending.